Okay. Assalamualaikum and good morning. uh, can you hear me? All right.
Yes, doctor. Yes.
Okay. So today we will continue. Well, can you see my what I'm sharing with you? Yes, right. Wait, Okay. So today we are going to go to the next subtopic. We already go through the inverse, right? Inverse, and then today we are going to go to the how we want to find the inverse by using how to move this one. Yeah, how to find the inverse Laplace by using the partial fraction. By using the partial fraction. So yesterday Yesterday we have learned the Laplace of delta direct function, direct delta function. Okay, and these are the formula. These are the formulas that you need to know. What will you get if you Laplace the direct delta function? So for the direct delta, the symbol you have the delta. This is the delta. So means that that is for the direct delta function. So you need to know lah what if you Laplace the delta t is equal to 1 and Laplace delta t minus a is equal to exponent negative es, and we have the ft here. Ft means that Fe. So if you are going to use this formula for the third one, you need to find Fe. Okay, so what is Fe? This is the proving part. Okay, so today we move to the this one. This one also right. Yesterday we already learned about the inverse Laplace transform, where for the inverse Laplace we have the power of negative 1, the Laplace power of negative 1 fs, capital Fs. So means that you want to find the small ft lah, small ft. So these are the formula as well. Actually, from the table, you can find both lah, vice versa. From capital F to small f, and from small f to capital F. You can just follow the table only. So for this one, we have the function Laplace of inverse Laplace of f s minus e, and then exponent es. Oh, wait, okay. 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 So, this one you also need to know what you want to get for the inverse Laplace. Can you see the slide, right? Okay, okay, okay. Actually, this is my first time using the Google Meet, so I'm not familiar lah. Can you see this one, the slide here? Okay. So, this from the yesterday for the inverse Laplace, we have we want to transform. Actually, if you want to transform for this calculation, you need to adjust or modify lah. Modify to get like what is in the table, the elementary table or in the formula. So for you to substitute into the formula lah. Okay, so today we are going to find the inverse Laplace transform. This one, today we are using the partial fraction. So hopefully you can memorize how, actually this one partial fraction you already learned from, maybe from the basic mathematical calculation from the, I'm not sure, maybe calculus or something like that lah, for the partial fraction. Okay, and then okay, so previously, we have seen few examples that involve fraction which can be written into expression that we have in the table. This is what I mentioned to you, that we just use the table and a little bit of manipulation or adjustment lah, or you need to modify the how you write the equation. So you can just right by using the table, the transform of the table lah. However, but if for this equation, this question, Laplace inverse 3s plus 1 over s square minus s minus 6, how can we rewrite the fraction? So for this one, if you compare the form of this equation with in the table or in any formula, Laplace formula, there is not similar to the form, the basic form. There is no similar to this question. So how you want to solve this one? Okay, like previously, if you look here, this one you have x square for this one, wait, for this one you have square, and this one you have 9 lah. So you may know that this one you get s negative 2 square, this one you get 3 square. Similar to this one, this is the power, so you will use the formula of this one, s minus a, or in the basic one you can use the t power of n here, 1 over s cube, s power of n. And similar to this one, you have s square plus 9 means that this is 3 square. So every time you see the question, you might know what is the formula that you need to use. Okay, how you want to know that one? By using, you do many exercise, lots of exercise. So for this one, there are no general form. There are no, not following any general form in the formula. Is there any? Okay, wait. Okay, so how we want to solve this one? There are few types of denominator that you should know. This is how you want to solve, by using the partial fraction. Fraction, I'm sure that you already learned from maybe the previous course, maybe calculus or something like that lah, about the partial fraction. There are a few types, the denominators. Number one is factor that s plus a, the partial fraction. S plus a give a partial fraction a over s plus a. This one. This is what you need to know lah. If there is a linear factor, so the partial fraction will give you a over s plus a, where e is a constant to be determined. You need to determine the constant of capital A here. Okay, and then after that, if the denominator is repeated factor like this, s plus a square, so it give you this one. This is this is the partial fraction for the repeated factor. And if, for example, this one s plus 2 until cube, so there might be another one. If the question is s plus a cube, so this will give you another terms lah. C, this is C over s plus a cube. And if there is another repeated factor until 4, so means that power of 4 means that you have to add another term, d over s plus a power of 4 and so on. Okay, that is for the repeated factor. And similarly, this one for the number 3 lah, repeated factor. And for the quadratic factor, for the quadratic factor that give you the ps plus q over s square plus ps plus q. You will get this one. Okay, if the quadratic factor. And for the repeated quadratic factor, s square plus ps plus q square give you, so you will get similar to the previous one. For the repeated factor, there is square, so means that your highest power of the denominator, you will follow until square as well. Okay, this one is 1 and square. So this one is ps plus q plus rs plus t and over the denominator. These are the partial fractions that you should know lah. Okay. So we go to this one also, you need to know lah. This is the basic knowledge that you need to know. Therefore, if you want, how you want to solve this one, you need to find the partial fraction first. Find the partial fraction. So 3s plus 1 over s square minus s minus 6. So you try to factorize first. Try to factorize the denominator here. So if you can completely factorize, so it's more easier lah for you to solve the problem. So you get s plus 2, s minus 2 from the factorization. And actually this one in the box here, we solve by using in the box first. Because we want to find a plus b. What is the value of a plus b first? What is the value of a plus b? You need to find you need to determine the coefficient of a and b. So how you want to solve this one? How you want to solve this one? This one you cross the product lah. Cross. So you get a s minus 3 plus b s plus 2. You equal to the left hand side here, 3s plus 1. And for the denominator, you can cancel out the denominator. You can cancel the value here. Because all the denominator has the same value, so you can just ignore the denominator. So we can just take the numerator only. So this is the equation lah. Okay, and then after that you can solve. How you want to solve this equation? You can let your s, we want to eliminate one of the coefficient. For example, you want to eliminate a to get the value of b. So how you want to eliminate a? You refer to this value, s minus 3. So we want to get a is equal to 0. So your s is equal to 3. So 3 minus 3 is 0. So it will become A is equal to 0 as well. So that's why how you want to determine the value of S depends on the in the bracket. You need to make sure that the amount substitute the value of S you substitute will get 0. Okay. So the first term, we want to make sure that your E is equal to 0. So the value of S is equal to 3, where 3 minus 3 is equal to 0. So you can eliminate the value of A and you can just get your B here. B, so by using S is equal to 3, B is equal to 2. Okay. And then similarly to the another value, S plus 2. So how you want to make sure that this is equal to 0? So you need to add by negative 2. Negative 2 plus 2 is equal to 0. So you can get the value of A. And then after you got the value of A and B, you substitute back into this equation lah. So your A is equal to 1 and B is equal to 2. So this is the value for the partial fraction. So you substitute back into the question, we get this. So means that you need to Laplace the new modified terms. You need to Laplace 1 over S plus 2 plus 2 over S minus 3. This one, you need to Laplace this term. Okay. And then after that, actually, there is another step lah. You can separately find Laplace, Laplace inverse 1 over S plus 2. You can do separately, plus Laplace inverse 2 over S minus 3. Okay. So for the first term, second term ni, actually you can take out the constant here. This is 1, this is 2 lah actually. Okay. So you can just, all the coefficient you need to take out from the Laplace that you want to do the Laplace lah. Okay, and then after that, from the table, you may look from the table, what is 1 over S plus 2? What is 1 over S minus 2? From the table, the elementary of the Laplace. So from the table, you can see that that is equal to exponent negative 2t, and the second one is equal to 2 exponent 3t. Okay. Is that clear? This is by using the question. And then any question? So the basic of types of denominator that you should know lah, if you want to answer this question. But actually, you need to know for the final exam. Okay, so there is another tips when dealing with the fraction. If the denominator is quadratic equation, polynomial degree 2, try to factorize the, this is what I mentioned to you just now, that you try to factorize the denominator first. And if it is possible, then proceed with the partial fraction decomposition. If not, do the completing the square to denominator to get the fs minus a function. Okay, so if there is a polynomial, the quadratic function, quadratic equation, so your first step is you need to try to factorize. Okay. However, if the question is if the equation cannot be factorized completely, so you need to do the completing the square. This is what I mentioned to you yesterday, that you need to study first. If you are not memorized how to do the methods, you need to Google first, study first about the completing the square. Okay. So this is the example. We go to the next one. Example 19. Determine Laplace inverse of 5s plus 1 over s square minus s minus 12. Okay, this one. So, this one, if you try to factorize the denominator, first you need to try to factorize the denominator here. So, by using the factorization, you get s plus 3, s minus 4. Okay, and then you separately you do a over s plus 3, you do separation lah, plus b over s minus 4. We write into this form. This is by using the partial fraction. Okay, and then after that, you times cross the product here. So you will get, actually you will get sorry, 5s. 5s plus 1 over s plus 3 s minus 4 equal to this one. You cross the product, you will get a s minus 4 plus b s plus 3 over plus 3 s minus 4. Actually, you get this one. So from this one, we can see that the denominator from left hand side and right hand side are equal. So you can just ignore the denominator because both are equal. So you can just take the numerator only. So that's why you will get this equation by using the partial fraction lah. You can get 5s plus 1 equal to a s minus 4 plus b s plus 3. And then you need to choose what is the value of s. So to get the a is equal to 0. So you can get your b. And after that, you need to get b0 to get the value of a. Okay. There are two possible value lah for s here. S is equal to, what is s is equal to 4? What will you get? And another one is s is equal to -3. What will you get for a? So after you do the calculation, please show, okay, the calculation. You will get a is equal to 2, b is equal to 3. And then after that, after you get the value of a and b, you substitute back into this partial fraction. The value of partial fraction. So you get 2 over, a is 2. 2 over s plus 3 plus 3 over s minus 4. And then you can separately do the Laplace inverse. So the constant, if you look here, there is a constant here. Constant, you can take out the constant from the Laplace form. So you will get 2 Laplace inverse 1 over s minus, this one you need to refer to the formula, okay, to the table. So from the table is negative. So that's why this is negative, minus -3. You need to modify lah the equation. Okay. And this one is negative, right? Minus. So you can just take lah the value Laplace. So from this one, you will get exponent 2 exponent -3t plus 3 exponent -4t. Can you check whether is it the same value here, negative and negative? Wait, the table, where is the table? Negative is positive, right? So exponent 80. This one, no negative, Wait, This one is just positive, no negative from the table. So you get 3 exponent 40. Okay. Follow from the table. Any question? No. Actually, for the partial fraction is quite easy lah, easy for you. For the what if you can do the factorization. Okay, so we go to the second the next example, example 20. The Laplace determine the Laplace inverse of 4s square minus 5s plus 6 over s plus 1 bracket s square plus 4. Okay, so by using the partial fraction here, there are for this question already given to you for the denominator already factorized. So you can just separately do separate the function. Is there okay, you can just separately do the partial fraction. So you can get a over s plus 1 plus this one is the polynomial. So polynomial there is bs plus c. bs plus c. So if you look here, there are three coefficients that you need to determine the value. There are a, b, and c. How you want to get this value? Similar to the previous example, this one you need to cross the product here. Cross the product, so you will get a s square plus 4 plus b s plus c, and then times with s plus 1 over the denominator lah, and this one equal to 4s square minus 5s plus 6, and then you ignore the denominator, you just take the numerator only, and then you can try one by one lah. S is equal to 0, s is equal to -1, and another one, I think you can choose any number, any real number. Okay, s is equal to 0, s is equal to -1, and another, because you already know for example 2 unknown, you already know, so the last one you can choose any real number, so you can get the value of a, b, and c. Okay, and then after that this is the value lah. a is what? A is 3, s b is 1, and s is equal to -6. You can get this term. And then after that, you can do the factorize. You can, by using the table. By using the table, you can find the value of inverse. So from here, this one modify the equation here. So s -1, and this one because we cannot separate s square plus 4 anymore, so the separate by using the upper term here lah. So s over s square plus 4, because this one you can use by using the table. You can look into the table, what is the value. Okay, so you can get this term is cos, and the other next the next term is sine 2t. Okay, because why is it this one is cos? Because there is the value of s here. You can refer to the elementary table Laplace. If s, so that is cos, and this is constant, so constant, it is sine here. Okay, so the answer is 3 exponent -t plus cos 2t minus 3 sine 2t. Okay, you can compare lah. Compare with the table, from the table. Okay, is that clear? So, for the partial fraction, how you want to solve by using the partial fraction? There are three ways. The first one is by using factorization. If you can completely factorize the equation, and the second is by using the this one, the few types of partial fraction that you should know how you want to do by using the partial fraction. And the last one is by using the completing the square. Completing the square. This is example 21 is by using the completing the square. So if you look, the question is determine Laplace inverse 2s minus 3 over s squared plus 2s plus 17. So from here, we can see that the denominator, you cannot factorize. It can be factorized completely lah. Okay. So we do the completing the square on s squared plus 2s plus 17. So how we want to do the completing the square? So I just recall back, show you example here. How you want to, hopefully you already learned lah from yesterday that I mentioned to you that please study first about the completing the square here. These are the steps. These are the steps for the complete the square. For example, this is the question for you. This is the question. So how you want to get this one? You need to find b over 2 here. B over 2 square. This is the expression. The factor is x squared plus bx plus b over 2 square. And you can factor. How you want to factors? You just take the square only. X plus b over 2. And you can square the equation. This is the example here. X squared plus 10x plus 9. So what is your b? B is 10. So 10 divided by 2 is equal to 5. Okay. And you need to square because b over 2 square. So 5 square is equal to 25. So you will rewrite x plus 5 square. The value here is 25. This is 25, right? 25, negative 25 plus 9. Negative 25 plus 9. And you can simplify x plus 5 square minus 16. Okay, if you want to completing the square, please make sure that the coefficient of a here must be 1. The coefficient must be 1. So from here, factor a from x term. This one you need to factor because we want to make sure that the value of coefficient a is equal to 1. Okay. This is how we want to do the completing the square. This one. So the formula is x plus b over 2 square minus b over 2 square plus c. This is the formula. Okay. So that is what you will get from this one. From this one. This is by using the completing the square. So you will get s plus 1 square plus 16. So from that formula, you will get s square. What is b? B plus 2s plus b over a. B is 2 over 2 square lah. And then minus 1 plus 17 by using this formula. Okay, I'm using this formula. Which one wait this one, b over 2 minus negative b over 2 square plus c. So you get this one 17 plus 17. So you how you want to completing the square, you just take the square only. Okay, the square is equal to s plus 2 over 2, you get 1 lah. You can simplify square. This one you can simplify plus 16. So the answer is similar like in the what I have written here. S plus 1 square plus 16. This is by using the completing the square. So you get this one, Laplace inverse of 2s minus 3 over s plus 2 plus 16. Okay. So because this one is about the what we call this one, we have s plus 1, we have the you can map to the this one, the formula of s minus a. Okay, s minus a, because you have s plus 1 here. And if you are using going to use this formula, you need to modify the upper part here, the upper equation, the numerator here, because your s minus a, this is s minus a, so you have to make sure that the amount, the value must be equal lah. This one s plus 1, the upper part also you need to s plus 1. So how you want to modify? If you open the bracket, you can get like in the previous equation. So how you want to get this one? So you already know that your s must be s plus 1. So you just write 2s plus 1. And the answer is negative 3. So if you expand this one is 2s plus 2. How you want to get negative 3? You need to minus with 5. Minus with 5, you get negative 3, and you can get similar equation like in the previous step. Okay. This one you need to modify lah the equation here. And then after that, from here, we can see that your A is equal to negative 1 lah. Your A is equal to negative 1. Okay. And your F, because this one is plus 1, right? So F s minus negative 1. So you get s plus 1. So you will get 2s plus 1 over minus 5 over s plus 1 square plus 16. So from here, you can see that your E is equal to negative 1. And you can make a conclusion that your Fs is equal to, you can just ignore of the value of negative 1 here. So you can just get 2s minus 5 over s square plus 16. This is your Fs. This is your Fs. So your Ft is equal to Laplace inverse 2s minus 5 over x squared plus 16 from your Fs here. And you can do separately, because this one you look here, there is x squared and 16. So that means that 4 squared is equal to 16. You may refer to the elementary table. And you can separately you get 2s over s squared plus 4 minus 5. 5, all the coefficient, the constant you take out from the Laplace. So this one, it will be given to you 4 over s squared plus 16 times with 1 over 4. Actually, this one is, if you take out the 5 here, actually it will become 1. However, from the table, the elementary of table, Laplace table, the formula is A over s squared plus a squared. So that's why there is 4 here. There is 4 here. Because this is by using the table lah. So that's why you have 4 here. And how you want to eliminate, how you want to cancel the value of 4? So that's why there is another term here. You need to times with 1 over 4. So you can cancel the value of 4. Okay. Why you want to cancel the value of 4? Because you can use the formula of this formula, the elementary formula. A over s squared plus a squared. So by using the elementary Laplace formula, this one, the first term is equal to cos 40 and the second term is equal to 5 sine 40. Okay. So you want to Laplace, wait, you want to eh, okay. So you want to inverse the Laplace of what is the star here? The function, where is it? The question here lah. The question here is equal to this one, this one. This is the star. You go back to the to the previous formula. What is the formula of Fs minus A? Okay, for the formula, this formula, there is an exponent, okay? Please don't forget to put the exponent negative t. If I'm not mistaken, the formula is exponent negative a. Not negative, I think A. This is, you check you check the formula. You check the formula of S here. This one is exponent 80. Exponent 80 F T. So what is your A? A is negative T. Ft, from the previous part, you already find the value. Okay. Is that clear? So basically, if you want to answer this type of question, you need to know and memorize all the formula. What is the formula of Fs minus E? Fs minus A is equal to exponent ATFT. Okay. Please don't forget, okay, about the last part here. This one, 1 mark lah for the final answer. Any question? No. Okay, wait I just want wait Okay, so maybe you can try from the exercise here. You can try this one, the partial test. Find the inverse of the following. This is from your past year, past year test 2. Is it test 2? Test 2. Okay, you can try number 1 first. Can you try? Okay, this one. So find the inverse Laplace of the following function. Exponent negative s over s square. Please try number 1, okay? Please try number 1. Anyone got number 1? For this one, maybe you can try later, for the past year test 2 here. This one, for the notes I already given to you. You can try number 1. This one, number B here. You can check whether you can do the factorization, factorize or not. This one, for the second term, you are using the basic elementary of Laplace. This one you check whether you can use the what we call the factorization, and this one already factorized, so it's more easier lah. You just try to get what is the value of E and B. Similar to the second question, number 2 here. How about this one, the first term exponent here? You can try how to solve this one. Exponent negative, this one exponent negative s over s squared. If you look here, there are similar question for number 1 and 2 here. There is exponent similar to this one as well. How we want to solve? Okay, this one you can just factorize. If you cannot factorize, means that you need to solve by using the completing the square. And this one is plus 3. This is the is it the repeated factorization? Maybe you can try it. Okay. So next week we are going to learn about the finding inverse Laplace transform using the convolution theorem. Okay, please learn and study first. There is the solution for you as well. So this one just one example only, but maybe you can try lah to solve this one. Oh, this one is just one subtopic, one example. It's okay. You can just solve this one first by using the partial fraction. Next, we are going to learn about the convolution and the what is this? The IVP and BVP. IVP and BVP. Okay, please try, okay? Please try the past year test 2 for number 1, 2, 3, and 4 here. Okay. Is there any question you want to ask? Okay, maybe I can take the attendance first. Okay, please scan for your attendance here. All right. Awesome. So next week, don't forget, okay, about your quiz 1. Quiz 1, we are going to do on Tuesday. Tuesday, maybe from 8 to 9 a.m. And then after that, we will proceed with class lah, online class. For the quiz, cover this chapter, Laplace, and that is the multiple choice question. I'm not sure yet how many question for the quiz, so you can just be prepared lah about the quiz. Maybe about the basic calculation, because that one is MCQ question only, right? So maybe some of the question maybe need to do the calculation, and maybe about the formula. Okay. So and that one is random question from the system, and not similar question for all the student. Okay. So it depends on the e-learning lah, about that one, because that one is from the random question. So for each student will not get the, if I'm not mistaken, I will not get the same question for the quiz one. So please make sure that you prepare that is quiz one. For the contribution mark is for 5%. 5%. Okay, so for next week, please learn about the next method, the inverse, but the next theorem is convolution theorem, by using the convolution theorem. And please study about solving IVP and BVP as well. IVP and BVP. This one now. Okay. Is there any question you want to ask before we end? All of you got scanned the attendance. Any problem with the attendance? No. Okay, all is good. Okay. Okay, I think oh, that's all for today. So we will continue your next class next week, Monday. And please learn about what I have mentioned to you about the convolution theorem and how you want to solve IVP and BVP. And after that, please do the exercise, okay? Past year test 2 just now, about the partial fraction. Okay. There is one. Okay. So I think that's all for today. Why there is still student want to join? Okay. I think that's all for today. See you next week. Okay. Right. Thank you. Assalamualaikum. Oh yes, Ryan. You want to ask something, Ryan?
Thank you, Doctor.
Okay. Welcome.
Thank you, Doctor.
When is the quiz, Doctor?
Sorry.
When is the quiz?
Tuesday next week. Tuesday next week on 19 May.
On e-learning, right?
Yeah.
Thank you,
Online.
Doctor.
All right. Is it okay, Ryan?
Yes, yes. Thank you, Doctor.
Okay, okay. Welcome. Okay, thank you all.